Hello, everyone. In this video, we are going to study the cross product and its properties. Cross product. The cross product of two vectors u and v is the vector defined by any of the following equivalent equations. The first equation writes the cross product as the determinant of a 3 by 3 matrix, where the top row contains the three standard basis vectors instead of numbers. That is why this is just a mnemonic device used to remember how to compute the cross product rather than an actual determinant. If we proceed with computing the determinant of the 3 by 3 matrix, the result is a vector that contains determinants of smaller 2 by 2 matrices. Finally, after calculating these actual determinants, the result is the final equation for the cross product of two vectors. The cross product of u and v is orthogonal to both u and v. That is, it makes an angle of 90 degrees with both u and v. The cross product of u and v is read as u cross v. Consider two vectors u and v, and theta be the angle between the vectors. The cross product of u and v is this vector that is perpendicular to both u and v. Which means it makes an angle of 90 degrees with u and v. U cross v is not the same as v cross u, because v cross u points in the opposite direction of u cross v. In other words, the cross product is not commutative. However, the negative of v cross u is equal to u cross v. Nevertheless, we learned that equal vectors will have equal lengths, and the length of a scalar multiple of a vector is equal to the absolute value of the scalar times the length of the vector. So the length of u cross v is equal to the length of v cross u. Angle between two vectors. If theta is the angle between the vectors, then the sine of theta is the norm of the cross product of u and v all over the product of their norms. For parallel vectors, that is, theta is 0 or 180 degrees, which means they point in the same or opposite directions, respectively. The cross product is the zero vector. Hence, the norm of the cross product is equal to 0. The dot product has a somehow similar property. For perpendicular vectors, that is, the angle between them is 90 degrees, then their dot product is equal to 0. Aside from using a graphing utility, the direction of the cross product can be visualized using the right-hand rule. Using the right hand, point the index finger in the direction of the first vector. Then point the middle finger in the direction of the second vector. Rotate the right hand if needed, while keeping the index finger in the direction of the first vector. Then extend the thumb out. The direction it points to is the orientation of the cross product with respect to the first and second vectors, and the actual direction still needs to be computed. As an illustration, consider the three standard basis vectors I, j, and k. For I cross j, if the index finger points in the I direction, and the middle finger points in the j direction, the extended thumb would naturally point in the k direction. So I cross j is equal to k. Using this technique, we can get the following cross products. For j cross I, if the index finger points in the j direction, and the middle finger points in the I direction, the extended thumb would naturally point in the direction opposite of k. So j cross I is equal to negative k. Using this technique, we can get the following cross products. If we want to find out the cross product of a standard unit vector with itself, recall that the cross product of two parallel vectors, whether they have the same or opposite directions, is equal to zero vector. So these cross products are all equal to the zero vector. This makes sense because there is no other vector acting on each vector besides itself, so the result is the zero vector. Properties of the cross product. Let u, v, and w be vectors and k be a scalar. Non-commutative. The cross product of u and v is equal to the negative of the cross product of v and u. This means that these cross products point at opposite directions. Distributive over vector addition. The cross product of u and the sum of v and w is the sum of the cross product of u and v and the cross product of u and w. Associative. The grouping of a cross product with a scalar does not change the result, which means a scalar multiple of a cross product is associative. However, the cross product is non-associative when involving three vectors. The cross product of u with the cross product of v and w is the difference between two vectors, the dot product of u and w multiplied to v minus the dot product of u and v multiplied to w. Scalar triple product. The dot product of u with the cross product of v and w is equal to the dot product of w with the cross product of u and v. The result of this operations is a scalar quantity. Meanwhile, recall that the dot product of orthogonal vectors is 0. Because u is orthogonal to the cross product of u and v, the dot product of u and the cross product of u and v is equal to 0. Likewise, because v is orthogonal to the cross product of u and v, the dot product of v and the cross product of u and v is equal to 0. The cross product also has other properties such as the cross product of a vector with a zero vector is commutative, and the result is the zero vector. Meanwhile, the cross product of a vector with itself is the zero vector. Later we will learn a more general case. Two non-zero vectors that have a zero cross product means they are parallel vectors. That is, u and v are scalar multiples of one another, and they point either in the same or in opposite directions. Finally, the cross product of two zero vectors is the zero vector. Example 1. Find the cross product of two vectors if they have the following values. Solution. The cross product of two vectors can be calculated by using the following equation. A. substitute the components of the vectors into the formula of the cross product. Therefore, the cross product of u and v is 3 square root of 3i minus 4j minus 2 square root 3k. b. Substitute the components of the vectors into the formula of the cross product. Therefore, the cross product of u and v is 21i plus 14j plus 10k. Example 2. Find the norm of the cross product of two vectors if they have the following characteristics. Solution. The norm of the cross product is the product of the norms times the sine of the angle between the vectors. A. Substitute the norm of u as 2, the norm of v as 3, and theta as pi over 6. Thus, the norm of the cross product is 3. B. Substitute the norm of u as 1, the norm of v as 1, and theta as 135 degrees. Thus, the norm of the cross product is square root of 2 all over 2. The formula works whether the angle is in radians or in degrees, as long as the calculator is set at the correct mode. C. Substitute the norm of each vector and the angle measure between the two vectors. But this leads to a dubious answer, a negative number, which is not possible as the norm of a vector. Suppose this is the graph of the two vectors. The given angle is the larger angle between the two vectors. Note that the exact components of u and v are not given, and only their magnitudes and the angle between them. So this graph is just one of many possible graphs of u and v. However, if the smaller angle was used in calculating the cross product, the norm of the cross product is a positive number. And this is the cross product of the two vectors, and it is perpendicular to both u and v. So for the angle between two vectors, use the smaller angle to get realistic results. Example 3. Find the angle between the vectors if u and v have the following values. Solution. Recall that the sine of the angle between two vectors is equal to the norm of their cross product divided by the product of their norms. A. Compute the cross product of u and v. The result is the zero vector, which means u and v are parallel vectors. Derive the expression for theta. Because the norm of a zero vector is 0, while the norms of the vectors are non-zero, this quotient is 0. The principal result is 0, which means the parallel vectors point in the same direction. However, u and v are not equal vectors nor scalar multiples that point in the same direction. But parallel vectors can also point in opposite directions, so theta can also be pi. Hence, theta is pi or 180 degrees. Let us draw the two vectors in 3D space. The computed angle is this angle between the two vectors. The angle between the two vectors is pi radians, or 180 degrees. This particular angle measure means that the two vectors point at opposite directions. In addition, because their norms are going to be the same, these vectors are called opposite vectors. And their cross product is the zero vector, which is a vector with a norm of 0 and an indeterminate direction, and therefore has no graph. However, we can tell if two vectors are opposite vectors by looking at their components. If the vector components of one vector is the negative of the vector components of the other vector, then the two vectors are opposite vectors. B. Compute the cross product of u and v. Use the derived expression for theta. Therefore, theta is pi over 2 radians or 90 degrees, which means u and v are not parallel, specifically, they are perpendicular. Let us draw the two vectors in 3D space. The computed angle is this angle between the two vectors. These vectors are called perpendicular or orthogonal vectors, because they point at orthogonal directions, which means the angle between them is pi over 2 radians or 90 degrees. The sine of this angle is always equal to 1. So this means that the norm of the cross product is equal to the product of the norms. And it points in the direction that is orthogonal to both u and v. C. Compute the cross product of u and v. Use the derived expression for theta. Thus, theta is 1 radian or 57.80 degrees, which means u and v are not parallel. Let us draw the two vectors in 3D space. The computed angle is this angle between the two vectors. The angle between the two vectors is 1 radian, or 57.80 degrees. And this vector is the cross product of u and v, and it is perpendicular to both u and v. Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.